Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question taken from JEE Main Mathematics question paper of 2024. The question is based on integration in which we are required to evaluate a definite integral. Read the question carefully. The value of integral between limits 0 to pi by 4 of dx divided by 1 plus tan x is equal to. The options are given in the question. We are required to find the correct option. Now for the solution. Let us write the given integral first. The given integral is I is equal to integral between limits 0 to pi by 4 of dx divided by 1 plus tan x. Now to this integral we will apply a rule applicable to definite integral. If the given integral is between limits 0 to a fx of fx into dx, then it can also be written as 0 to a f of a minus x into dx. We will apply this to this integral. Applying the rule, we get I is equal to integral between 0 to pi by 4 dx divided by 1 plus tan pi by 4 minus x, because dx remains unchanged when we write f of a minus x into dx. Now let us first evaluate the value of tan of pi by 4 minus x. Using the formula for tan of a minus b, we get tan of pi by 4 minus x is equal to tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. Putting tan pi by 4 is equal to 1, we get tan of pi by 4 minus x is equal to 1 minus tan x divided by 1 plus tan x. Let us put the value here, which gives I is equal to integral between limits 0 to pi by 4 of dx divided by 1 plus 1 minus tan x by 1 plus tan x. Let us simplify this. Therefore, the denominator becomes 1 plus 1 minus tan x divided by 1 plus tan x, which is equal to, the common denominator is 1 plus tan x, and we have got in the numerator 1 plus tan x plus 1 minus tan x. Now tan x gets cancelled, which gives 2 divided by 1 plus tan x. Therefore, we get 1 plus 1 minus tan x by 1 plus tan x is equal to 2 divided by 1 plus tan x. This is in the denominator. So let us write it. Therefore, I is equal to integral between limits 0 to pi by 4, 1 plus tan x divided by 2 into dx. Let us remove this. So keeping 1 by 2 outside the integrals, we get I is equal to half into limit integral between limits 0 to pi by 4 of dx, 1 into dx is dx, plus integral between limits 0 to pi by 4 tan x into dx. Let us remove all this and put it there. Now let us evaluate the integrals. Therefore, we get I is equal to 1 by 2 into integral dx is equal to x plus integral tan x dx is equal to log sec x between limits 0 to pi by 4. Because we have the same limit in both cases, we have put the common limits. Putting the limits, we get I is equal to half outside. X means upper limit minus lower limit, pi by 4 minus 0 plus log sec x. In place of x, we put x by 4 and then minus 0. So log sec pi by 4 minus log sec 0, which gives I is equal to half into pi by 4 minus 0 is pi by 4 plus half into log sec pi by 4 is root 2. Therefore half log root 2 minus half log sec 0 is equal to 1. And log 1 is equal to 0. Let us remove this term totally. So we are left with I is equal to half into pi by 4 plus half log root 2. Now let us remove this and put it there, which gives I is equal to half of pi by 4 is pi by 8 plus half log root 2. Let us write this as half log 2 to the power half. Now I is equal to pi by 8 plus that log 2 to the power 1 by 2 becomes 1 by 2 into log 2. Therefore we get I is equal to pi by 8 plus 1 by 2 into 1 by 2 into log 2, which gives I is equal to pi by 8 plus 1 by 4. 1 by 2 into 1 by 2 is 1 by 4 into log 2, which is the answer to the question. This is the answer. So let us find the correct option. Option 4 is the correct option. So let us write that. Option 4 is the correct option. This completes the answer to the question. Thanks for watching.